You are welcome to this second lecture on Laplace transform. This video presents Laplace transform of two hyperbolic functions, translation and change of scale properties, Laplace transform of derivatives, Laplace transform of integrals, multiplication by power of t.
Okay, you're welcome. Now, before we proceed, let's remind of ourselves certain things. We consider in the first class that Laplace transform is just like a conversion of a function from t domain to f of x. Do you remember? And I introduced the expression to you, which is Laplace transform of f of t is equal to integral from 0 to infinity e minus st then f of t dt. And consequently, we consider something like Laplace transform of 1 to be equals to what? You remember 1 over x, and there was a condition which says that x must be greater than what? 0. Another thing again we consider Laplace transform of what? Of t, and we discover that this will give us 1 over what? X squared. You notice, of course, we can still say something like x is must greater than 0. And another thing we've learned from this one is that even 1 is a, if we have t raised to power n, this t raised to power n will give us n factorial over xn plus 1. Of course, n must be greater than what? 0. So now let me remind you now, if I should ask you to find Laplace transform of t raised to power 3, what would that one give us? Laplace transform of t raised to power 3 will give us 3 factorial over x3 plus 1. That is 3 times 2 over x raised to power what? 4. What if I just find Laplace transform of t raised to power 10? So Laplace transform of t raised to power 10 will give us what? 10 factorial over x raised to power what? 11. That's 10 plus 1. And that's not all. Last class again, we also considered the Laplace transform of exponential. And do you remember that I said that Laplace transform of exponential at is equals to 1 over x minus a? Okay, so from this, it's very simple now. You will now say that we can say the Laplace transform of exponential 5t is equals to what? 1 over x minus 5. Are we together now? Okay, let's consider another one again. Let's consider something like Laplace transform of exponential 2t. Of course, you know what this one will give me. This one will give me 1 over x minus what? 2. Now, what about Laplace transform of exponential minus 2t? That one will now give us 1 over x minus 2. That is 1 over x plus 2. Are we together now? Okay, so that is not all. We also consider in last class Laplace transform of sine and cos. So let's say Laplace transform of sine at, which is equals to a over x squared plus a squared. Then what about Laplace transform of sine 10t? Laplace transform of 10t will give us what? Will give us 10 over s squared plus 100. That is 10 squared. So what about Laplace transform of cos at? I said, if you remember my explanation, I said this is very simple. See, this is x. This x will be the numerator. So that will be what? X over x squared plus a squared. So which is the Laplace transform of cos 10t is equals to x over x squared plus 100. Please take a look at this again. Look at it very well. Look at it. If it is sine, then it's a. If it is cos, it is x. If it is sine at, look at this one. Sine 10t, you have 10 over. If it is cos, you have x. See, x at the back. X. Okay, that will help you to remember. So we've considered sine and cos. Now look at that again now. So today we are going to continue with Laplace transform of hyperbolic functions.
Now, so let's continue.
we want to focus on the Laplace transform of hyperbolic functions. So you can see now, if you open your lecture notes, page 9, you will see the assignment there. We have a Laplace transform of sin at, as you can see here, and that is correct pronunciation anyway, sin, cosh, tan. So, and another example, another assignment is cosh at. So in this class now, we'll solve one, then you will do the remaining. So let's consider this sin at. The first assignment is that we are asked to find the Laplace transform of hyperbolic functions. So we have it to be, we have three of them. That's sin at, we have cosh at, and we have tan at. These are the three hyperbolic functions. So we are looking for the Laplace transform of sin 80. I'm going to solve the first assignment, then you will go and solve the remaining. So if you look at this very well now, you expect me to write a 0 to infinity, then sin 80, then e minus st dt. But if you look at it, we're going to have issues with this integral. We're going to have issue with this. But you will know, you will recall that sin 80 is actually the same thing as exponential 80, then minus exponential minus 80 divided by 2. Very simple now. Can you see clearly now? So instead of me to battle with this, I can come and use this one. So which I can say the Laplace transform of this one is 0 to infinity, then e80 minus e minus 80 divided by 2 in a bracket, then multiplied by exponential minus st dt. Now, if you look at this very now, the next thing for me now is to evaluate this. So how do I go about it? Let me expand. Then I can bring 1 over 2 to come outside, isn't it? Then I will expand. So this one will give me 1 over 2 is 0 to infinity. Are we together? Then by the time you expand this and this, then you have exponential a minus x multiplied by t. Then the next one is this, minus this and this again will give me exponential minus outside, then a, then plus x multiplied by t. See, look at this, minus times a t will give you this, then minus times xt will give you the second one. Then let's use a big bracket, then we write dt. So what is the next thing now? The next thing now is for us to find the integral. So you can see now that here we give you 1 over 2 in the bracket. By the time you find the integral of this one, this will give us exponential a minus xt divided by a minus x. Then minus this one too will give me exponential minus a plus xt divided by minus into bracket a plus x is 0 to infinity. So now the next thing is for us to now evaluate the integral, what we obtain at 0 and infinity. So don't forget, you remember that in the class, in the first class, I said limit as t tends to infinity of exponential a minus x multiplied by t is actually 0. So which means that by the time you put infinity here, you get 0. The corresponding everything here will give us 0. The same thing applicable to this one too. You know, we are going to evaluate at infinity. So take note of this. Don't forget this. Let me show it for you very well. Can you see clearly now? So limit as t tends to infinity, exponential minus as multiplied by t is actually what? 0. So let's come back now. This one will now give us 1 over 2 into bracket. So you put infinity here, you have is 0. Then minus, you put is 0 here. Then you have 1 over a minus x. This minus is still here. Are we together now? But it's better for us to now put brackets now. At this point now, let's put brackets because we want to evaluate the other side too. So by the time you put infinity here, you have is 0. Then minus, by the time you put is 0 here, you have 1 over minus a plus x. So let's close the brackets now. So what is the next thing now? We have it to be 1 over 2 into bracket. This one here will give me 1 over x minus a. Do you see? Can you see? Minus will affect this one. So this one will change. Then you have this. So what about this one too? Minus 10 this will give me plus. Then you have plus then 1 over minus into bracket a plus x. Can you see clearly now? So what we have in here now is this. We need to join these together. How do we join it together? Let's find the LCM. The LCM will give us x minus a. Then even this one, this one I can express this one to give me something like that is minus a minus x. Of course, minus a minus x. So let's close the bracket. So everything a divided by x minus a will give me this. So that will be minus a minus x. Then I will have plus. Then everything here divided by this will give me x minus a times 1. That is x minus a. So you will see now that I still need to expand the denominator, so that this time this will give me minus xa. This time this will give me minus x squared. This and this will give me plus a squared. This and this will give me plus ax. You see that? Let me show you now again. This and this will give us the first. That is minus sa. This and this, that's minus s squared. Then this and this, that is plus a squared. And this, that's plus ax. So let's undo the top now. You will see now that this and this, they will give us 0. And this will give us minus 2a. Look at that. Will give us minus 2a. So let's close the bracket now. And look at this one again. This one too, we cancel this one. So you will see clearly now that 2 we cancel 2. So what now remains is minus a divided by, what is that? That's minus x squared plus a squared. There's one more thing again. But we can now say that Laplace transform of sin at, which is equals to 0 to infinity e minus st, then sin at dt is now equals to a divided by, then if you multiply minus, now you don't give you s squared, then minus a squared. Now that's what we obtain, but that is not all. There is a condition attached to it. Don't forget, I've told you, whenever you have denominator like this, negative sign, you need to emphasize on the fact that xm must greater than absolute value of a. That is the only condition that can give this denominator to be a positive number. So I will stop now. You will see the second assignment, that is Laplace transform of cosh. That is what you will do and send to me. Thank you. So let's proceed now.
Before we continue with this class, some of you, I know you will still feel not comfortable that why are we dealing with all those problems? Why do we need to find this? Why do we need to find that? Why do we need to find this? But you can see on the screen now, there's a picture of a man there called Steve Ballmer. He's the former CEO of Microsoft, owner of the Los Angeles Clippers. And look at this story. You will see something. They said he graduated magna cum laude from Harvard University with a bachelor degree in applied mathematics. Can you see that? He's a CEO, but he studied mathematics. Look at this one again. This is Sergey Brin. He's the founder of Google. Can you see that? Look at that. He also studied mathematics. Look at this man again. This is the founder, CEO of Netflix. Guess what? He also studied mathematics. Look at it. He studied mathematics at Bowdoin College. And look at the fourth person again. That is Jeffrey R. Immert. He's also the CEO of General Electric Immert. Can you see that? Look at this man too. He studied applied mathematics. Look at the fifth person now. CEO of PepsiCo received a Bachelor of Science degree in physics, chemistry, and mathematics. So we now see that all this thing we are studying is just to equip us with certain skills. Serious. That is why you can see that many departments are offering this course called MTS 209, Elementary Differential Equation. So don't find it difficult. Just try your best to understand. You will see that at the end of this course now, this course will help you to acquire certain skills. It will help you to see things, to understand abstract things. It will help you to understand certain skills. In fact, many. So I will encourage you, please don't run away from the course. Just love it. As you can see, I know you too, you want to be CEO in future, right? Please, just try your best, okay? Come back. So let's continue now. there's a classwork on the board now. We are asked to find the Laplace transform of this long function. It's a combination of polynomial, exponential, and trigonometric. So let's find the Laplace transform of this one. So we pick it one after the other. So this one here, that's t raised to the power 4. That will give us 4 factorial over x raised to the power 4 plus 1. That is why we have x raised to the power 5 here. Then you multiply by 3. Next one again, minus you still come here. So we have 3 factorial times 2. Then divided by x raised to the power 4. Then the next one again, we have s4 exponential minus 3t. So this one here will give us, don't forget, the Laplace transform of an exponential. That is 1 over x minus 3. Then that will give us plus. And don't look at this one, sine. Sine is actually what? That is 5 over this 5 here. A, remember the formula. Sine, Laplace transform of sine at. That is what? A over x squared plus a squared. So that will give us this one and this one. So that is that. And don't forget this one again. Note that Laplace transform of t to the power n is in the n factorial over x n plus 1. This is true for n equals to 1, 2, 3. Now we have one question on the board. We are given the function f of t to be a function, and in fact is a constant function because the function is 5 when t is 0 and 3. The function is 0 when t is greater than 3. So we have to find the Laplace transform of this function. So it's very simple. Look at what we are going to do. Laplace transform of f of t is what? Is 0 to infinity e minus s f of t dt. So let's break it down now. Look at it. The first one from 0 to 3. So we have 0 to 3, then e minus st multiplied by 5 plus 3 to infinity e minus st times 0. This 0 will come by dt. So what's the next thing now? Page 10. By the time you know this one, the 5 will come outside. So by the time you integrate exponential minus st, and this one is 0. By the time you integrate, this one will vanish. So we have this expression on the board. So we have 1 minus, do you know why we come up with 1? By the time you put 3 here, you put 3 first. And then it will not be minus, don't forget that we have minus there before. So by the time you put 3 here, what you have is exponential minus 3s. Exponential minus t is t that we are changing to 3. That's minus 3x over minus x. Then by the time you put 0, n to the power 0 is 1. Don't forget you have minus. That is when we put 0. That is why we have plus here. That's why we have plus here because it's going to be minus, upper minus lower. So that minus will multiply this minus to give us plus. So let's consider another example on the board. We are asked to find the Laplace transform of 2 exponential minus t plus t. Now this one, we first of all undo the first one, which means that Laplace will take care of the first plus Laplace will take care of the second. Is still correct. So this one will give us 2 over, don't forget that Laplace transform of exponential at is what? 1 over x minus a. So, and that of t is 1 over x squared. So you can see now here, we find the LCM here. And when you find the LCM of something like this, it's better for you to multiply it. So you have x squared multiplied by x plus 1. So everything here, denominator here divided by x plus 1 will give you x squared. The x squared times 2 will give you 2x squared. Then plus everything here divided by x squared will give us x plus 1. The x plus 1 times this one will give us x plus 1. That is what we have here. So that is the Laplace transform of 2e minus t plus t. Let's proceed again. What is the Laplace transform of 2 sine 3t plus cos 3t? Very simple. Let's break it down. Laplace will take care of this, Laplace will take care of this. So we have this expression, and look at it now. 2 Laplace of this, then Laplace of cos 3t. Don't forget, sine at, Laplace of sine at is what? A over x squared plus a squared. What about cos at? That is x. Remember I said x. We take the numerator over x squared plus 9. So don't forget, this is 3 squared. So we have, by the time you multiply 2 times 3 will give you 6. Then by the time you find the LCM of x squared plus 9 squared plus 9 is the same thing as x squared plus 9. So this and this will give you 1. 1 times 2 times 3, that is x. Then we have 6.
You are welcome. The next thing we want to consider now is translation and change of scale properties. Why do we need something like this? We need it because it will help us to easily find the Laplace transform of function like this, multiplying exponential 3t. It will help us to easily find Laplace transform of function like this, multiplied by exponential minus 2t. It will help us to solve something like this. Can you see it? Because the only thing we need to know here is this. We need to find the Laplace transform of what? Of t squared. And we already know that Laplace transform of t squared is what? Is 2 over, of course, 2 factorial, isn't it? That is 2 factorial, then over what? Over x 2 plus 1, that's 3. In this case too, we need to find Laplace transform of what? Of sine 4t. And what is the Laplace transform of sine 4t? That is actually the same thing as 4 over x squared plus 4 squared. That's what? 16. What about this one too? We need to find the Laplace transform of what? Of cosh 3t. And cosh 3t will give us what? That will give us x over x squared minus 3 squared. That's what? That's 9. In this case, we need Laplace transform of what? Laplace transform of sine 3t, which will give us, what is that? It will give us what? That is 3 over x squared plus 9. So by the time we know this, we can now see that it's very simple to find the Laplace transform of this. But before we proceed, let us try to see what translation change of scale property is all about. Now, let me introduce. The property is this. Let's say we have EAT, and then it is now multiplied by f of t. And we want to find the Laplace transform of this. We want to find the Laplace transform of this. You can now see, look at it. Laplace transform of EAT f of t. You will know that this is the same thing as what? Is 0 to infinity, then EAT f of t, then e minus st dt. So what do we need to do now? Let us try to join this and this together. If we join this and this together, it will give us 0 to infinity, then e exponential, that is a minus x multiplied by t, then f of t dt. Now, if you look at this very well, you see that it's very simple. Because what? I can rewrite this one to give me 0 to infinity, then exponential minus should come out here to give me x. Are we together? Then minus a multiplied by t. Look at this. This and this, that will give me this. This and this will give me plus at. Then f of t dt. Do you notice now that if you change everything here to be x, are we together now? That means that in the first case, when we started, remember when we started, we said Laplace of f of t is equals to 0 to infinity e minus st f of t dt. Can you see now? So which means that the only thing that has changed now is this. Let me cover it. The only thing that has changed now is that instead of having ordinary x, we are now having x minus a. So we can say that this thing here is equals to f of x minus a. Just like in this case, this is the same thing as what? F of x. So if this is f of x, then it means that, so what we are trying to say in a nutshell is that, let me put a box here now, is that Laplace transform of exponential at f of t is equals to f into bracket x minus a. Are we together now? F into bracket x minus a. So as simple as that. So let's continue now. So if you continue now, we are going to use this principle to solve these 4 problems on the board. So let's consider the first one. The first one, we want to find t squared e to t. Now, we know t squared to be this. Now, what is now the same thing as Laplace transform of t squared e3t? This one will now give us, let me write it here, right? That will now give you 2 divided by x minus 3 raised to power 3. Can you see that? Do you know? Look at my 3 here. This is my 3 here. This 3 here is the same thing as a in this case. So when this one is a, we have to be minus a, right? And here now, when it is 3, we have to be minus 3. Can you now see? This is as simple as that. That is all. Now let's consider another example again now. We know the Laplace transform of sine 4t, but we don't know Laplace transform of e minus 2t sine 4t. So this one now means that Laplace transform of e minus 2t sine 4t is equals to, look at what I'm going to do. 4 divided by, instead of writing ordinary x here, look at this. This is a, then minus a. This is minus 2. It will now be what? X plus, or let me write x minus minus 2 squared to make it sure that you can understand. Can you see that now? Because in this case now, when it is minus 2, then that will be x minus minus 2. Then this will give us 4 divided by x plus 2 squared, then plus 16. Now let's consider another example again. In this case now, we have Laplace transform of exponential minus 2t cosh 3t, but we know Laplace transform of cosh 3t to be x over x squared minus 9. So what we're trying to say here now is that Laplace transform of e minus 2t then cosh 3t is now equals to x. Don't forget, see, look at it. This is a minus a. Now this is minus 2 now. This is minus 2. You can see here from, let me underline it, minus 2. So this one will give us x minus minus 2. Wherever you see x, you attach it to it. Then divided by, this one will now be x minus minus 2 squared minus 9. So from here, you can see clearly now that what we are trying to say here, this one is like x plus 2 divided by x plus 2 squared then minus 9. So let's consider another example again, which is this example on the board. So what we need to do here is that we know Laplace transform of sine 3t already. Look at it. Can you see it clearly? Okay. So that's 3t, and this one is actually equals to 3 over x squared plus 9. So now Laplace transform of 2 exponential 3t then sine 3t is equals to, that will give us 3 divided by, what about this x now? Now look at it, this is 3. So that will give us what? That will be x minus 3 squared then plus 9. So if that is the case, we can expand this. You can now see now that we, using this translational and change of scale properties, we can now see that it's very simple for us to find Laplace transform of a complex things like this, multiplying. But note, one thing you must know that is that exponential is there. Exponential must be there. Exponential must be there. Exponential must be there. Oh, I think this one, of course, multiply by 2. You know, I have 2 here. So multiplying by 2. So I have that one there. So the only thing now is that you need to make sure that, because here, if we have EAT, from here we can answer that Laplace of EAT f of t is equal to fx minus a. So this is what we call translation and change of scale properties. Let's continue.
Next is to show you the Laplace transform of third derivative.
I believe you understand Laplace transform of derivatives. So, first derivative, we have worked on that and we discovered that Laplace transform of first derivative is minus f of 0 s f of x. And that of second derivative, you can see. And that of third derivative, which is actually a classwork I've explained to you. Now you see what it's all about. So the next thing now is to proceed to Laplace transform of integrals. Laplace transform of integrals. So let's consider this statement. If Laplace transform of f of t is f of x, then Laplace transform of integral from 0 to t f of u du is now equals to f of s divided by x. That is the statement. Laplace transform of f of u from 0 to t is equals to f of x divided by x. Let's prove it. Now, what we need to do is this. What is inside here? This integral that we want to deal with, this integral, let's call it g of t.
what is inside there. Let's call it g of t. That's how you can say g of t is equal to 0 to t f of u du. That is our equation 1. Now let us differentiate both sides. If you differentiate this one, you have g of t. If you differentiate this one with respect to u, so if this side too, we have d du of what we have here. Now the next step is this. If this derivative, we take care of this integral. Do you agree with me? So if that is true, then you now say that we have f of u, but from 0 to t. Now what is next thing now? We evaluate again. We put t here minus when we put 0 here. So we now have f of t minus f of 0. That is our equation 2. Now from equation 1, we need g of 0. What do I mean from this equation 1? We need g of 0 is that put is 0 here. By the time you put 0 here, put is 0 here too again. So the integral is now from 0 to 0. And remember, integral from 0 to 0 is what? Is 0. So if you put 0 here, 0 to 0, then we give us 0. That is why we have equation 3, that g of 0. That is 0 to 0 of 0 du. Now let's go back to equation 2 now. From this equation 2, we can now find the Laplace transform of both sides of equation 2. Which that we find the Laplace of this, we find the Laplace of this. So Laplace of this one now, we give us Lg prime of t, and Laplace of this one too, we give us what we have here. Now look at this one, each of them can take Laplace. So this one we take its own Laplace, this one we take its own Laplace, then we have Laplace f of t minus Laplace of f of 0. Now we need to find Laplace of f of 0, which is 0. How do I know it's 0? It's very simple. Come back to f of 0 here. Come back to f of 0. Where is that? We are looking for f of 0. Where is it? Let's go up. Let's come up. Okay, from here now. From here. By the time you put 0 here now, you will see that f of 0 will give us 0. And me, from here, even not even consider, put f of 0. You remember that Laplace of put is 0 here, f of 0. By the time you put is 0 here, are we together now? Then go back to the definition of Laplace transform. You will see that it will now be from 0 to infinity of 0. So that will give us 0. So that is why we know that Laplace of f of 0 is what? Is 0. So that is not all. We proceed again. Now, if this is 0 now, if this side here is 0, then what remains is this one is equal to this one. That is how we obtain our equation 4. Now, from equation 4 now, do you notice that Laplace of first derivative is what we know before? The Laplace of first derivative is what? X, Laplace of that function minus g of 0. Lg of t here is the Laplace of, before we said it's f of small x. Okay, so let's come back here now. So this expression here now, we use this one here to represent, to put it down the right hand side of equation 4. So that will give us this thing here, we put it down here. So you now have SL g of t minus g of 0 is equal to what? Laplace of f of t. Now, substituting equation 3. Equation 3, we know that g of 0 is what? Is 0. So g of 0 is what? Is 0. Now recall that Laplace of f of t is what? F of x. So Laplace of f of t now, this is this side. This side here, we change to f of x. So finally, we can now say that Laplace of g of t is equal to Laplace of, if we return at g of t, which is 0 to t f of u du, then is equal to this. So by the time you divide it, x is here before, then x will come and now f of x over x. So how do we use this formula, this thing that we've just obtained now? It's very simple. Let's consider example 1. We want to find Laplace transform of f of t is f of x, then Laplace transform of 0 to t f of u du is what? F of x over x. Now let's consider this expression now. We know that Laplace transform of sine 2t. What is the Laplace transform of sine 8t? Laplace transform of sine 8t is what? Is what? That is a over s squared plus a squared. So then Laplace transform of sine 2t is what? 2 over s squared plus a. Now what is that Laplace transform of 0 to t sine 2u du? Can you now see now? Because we already know that of sine 2t. Look at sine 2t now. Sine 2t is what? Then divided by what? By x. So don't forget that this one over this multiplied by divided by 1 over this, then this one will turn again. Then you have 2 over x squared plus 4, then x will come here to give us this expression. So that is how to find Laplace transform of what? Of integral. Now let's take a look at the last subtopic of today. This topic is all about multiplication by powers of t. Now let me explain now. Look at it now.
we have Laplace transform of f of t is equal to f of x. Now, if we now have t raised to power n f of t, what does that mean? That simply means that minus 1 raised to power n derivative of f of x in n time. You don't agree with me? Let's take a look at this example 1 now. T here raised to power 1 f of t. Now, it's same thing as minus 1 raised to power 1. You know, n is 1. Then the derivative, we differentiate f of x once. It's very simple. Look at it now. Let's assume that this one is t squared now. If this is t squared, then that would be what? Minus 1 raised to power 2, then d squared ds square of f of x. How do we obtain this expression? Let's take a look at it now. Laplace of f of t is 0 infinity e minus s f of t dt equals f of x. Now, let's differentiate both sides with respect to x. I'm talking about from here, this one is equal to this. If you differentiate this one with respect to s, you have df ds. If you differentiate this one with respect to s, you have d dx of 0 to infinity e minus s f of t dt. So what is the next thing now? Look at this. d ds will come inside. So we have d ds of e minus s f of t. Now, what is the next thing now? If you differentiate this one, you have minus t. Then minus the e minus s f of t dt. Now, look at it again now. Minus will come outside. That's how you have minus a. Now, we now have e minus s f of t dt. Look at this thing. T f of t. So, which one? This is the same thing as Laplace of t f of t. So, if you agree now, we now have minus, instead of writing this whole thing, we now write Laplace of t f of t, which is this one. Now, remember, we are dealing with the f there. So, minus will come here. So, because it's t, then you can now see that we have minus 1 raised to power n, which is raised to power 1, which you see give us minus 1. So let's consider this example now. Use the method of multiplication by powers of t to evaluate Laplace transform of t sine at. Solution. Very simple. What is Laplace transform of sine at? Is what? A over s squared plus a squared. Now, what is now the Laplace transform of t raised to power 1 sine at? That means that we are going to differentiate this one once. Then we multiply by minus 1 raised to power n. So that's why you can see the formula here. Minus 1 raised to power 1. Then we differentiate sine 8, Laplace transform of sine 80 once. How do we differentiate it? Look at it. This is quotient. We have u, we have v. So look at this now. Recall that if we have, oh no, take note of this one is divided. There's division here. There's division here. So if you divide this now, there's division here. So that is v the u ds minus u dv ds over what? V squared. From here, my u is what? A. My v is what? X squared plus a squared. So what is the u dx? U ds is what? Is 0 because this is a, not x. Now what is the v dx? The v ds is what? 2x. So let's take it back to that formula. Minus 1 raised to power 1 will give you minus 1. So this is now b the u dx minus u dv ds over b squared. So look at this one now. The 0 we multiply this one, then this one will give us minus 2ax over x squared plus ax squared. So what you can see here now, this thing is not the same thing. This thing here is not the same thing as Laplace transform of t sine a t. But do you know that you can, what can you do again? That's all. Let's take it like that. Now, but if, look at this one, let's assume that we have t squared sine 80 here now. You know that that will be what? Minus 1 raised to power 2, the 2 dx raised to power 2, then of the function. So let's consider another example. Now we have Laplace transform of t squared cos 80. Here we have t squared. You know here n is what? N is 2. So that is what? Minus 1 raised to power 2, then the square, the s square of Laplace transform of cos 80. What is Laplace transform of cos 80? That is what? X over x squared plus a squared. So we need to differentiate this one twice. So let's do it one after the other. Look at it. This one is just to show that we are differentiating twice. Let's differentiate the first time. The first time, this is x, this is, so our u is x, our u ds is what? If you differentiate u equals to s, you have 1. If you differentiate v equals to s squared plus a, you have what? 2x. So Laplace of t squared cos 80 is now equals to what? Minus 1 squared, then d dx of v du dx. You know we still need to differentiate the second time. That is why you can see this one here. So by the time you put everything back, minus 1 raised to power 2, then you differentiate the second time again. To differentiate the second time again, you have your u is now equals to this, then you have the u, then you differentiate, So after that, you put minus 1 raised to power 2, then you expand, you factorize, and that is all. As you can now see, we have example here. Look at this one now. Find the Laplace transform of each of the following function. In each case, specify the value of x for which the Laplace transform exists. 2 exponential 40, that is what 2 over what? X minus 4. The x must be greater than 4. That is a condition. That is why I said that specify the value of x for which the Laplace transform exists. Laplace transform only exists if x is greater than 4 here. Now what about this one too? 3 exponential minus 2t, that is what? 3. Then exponential x minus 2, that is x plus 2. This is true if x is greater than minus 2. Then the last one again, we have ft minus 5, and that is all. So you can see, so far so good. We've been able to consider Laplace transform of hyperbolic function. We consider when we have a long function, we take it one after the other. Then we do that. And we remind ourselves of Laplace transform of t raised to power n. And at the same time in this class, we consider a case whereby function f is discrete. It's a discrete function. Then we consider that one too. And then we now consider, we've treated translation and change of scale properties in this class today. So, and that one is very simple. That is when we have EAT f of t. And what does that mean? It means that this is equal to what? Fx minus a. That is what we have here. And we consider some examples of translational and change of scale properties. So we have example 1. Look at this one now. For you to do this one is very simple. Just go and find Laplace transform of t squared, then you extend it to that of e exponential 3t. So we consider all these following examples, and at the same time we consider Laplace transform of derivative. We consider first derivative, second derivative, third derivative, and at the same time we consider Laplace transform of what? Of integrals. Now at the end of this integral, we prove the statement, the derivation, and from here you can now see that if I ask you to find Laplace transform of 0 to t sin u,
we share
tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.